Welcome to EDU World Space.
All right, guys, we're doing chapter 9, problem 92, chemistry central science. The lactic acid molecule gives sour milk its unpleasant sour taste. Part A, they wants to draw the Lewis structure for this molecule, assuming the carbon always forms 4 bonds in its stable compound. And we have that Lewis structure right here. Now, part B, they want to know how many pi and how many sigma bonds are in this molecule. Now, for pi bonds, remember, for a double bond, you're forming 1 pi bond. For a triple bond, you're forming 2 pi bonds. For a single bond, you're forming 0 pi bonds. So we have 1 double bond here, so that's going to be 1 pi bond. And remember, double bonds are composed of 1 pi bond and 1 sigma bond. So we have 1 pi bonds here. Now we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma bonds. Now, for part C, which CO bond is shortest in the molecule? And that's going to be this one, this CO bond. Because double bonds are shorter than single bonds, so the CO double bond is going to be shorter than any of your CO single bonds. Now, for part D, what is the hybridization of the atomic orbitals around the carbon atom associated with the short bond? Now remember, if you see carbon forming a double bond, then that so you can tell what the hybridization is based on the number of electron domains surrounding your atom. If you have 4, then you're sp3 hybridized. If you have 3, sp2, 2, then you're sp hybridized. And you can see that you have 1, 2, 3. Even though you have a double bond here, that still does count as 1 electron domain. So that means if you have 3 electron domains, then you are sp2 hybridized. Now, for part E, what are the approximate bond angles around each carbon atom in the molecule? Yes. So both are yes. So you're going to look at your molecular geometry, and you're going to see you can approximate the kind of bond angles you see. The kind of bond angles you are going. You can look at your molecular geometry. You can look at the bond angles for specific structures, whether it's tetrahedral, octahedral, trigonal planar, and you can approximate your bond angles. So let me just get rid of these 2 blue things. That way it's easier to see. In fact, hold on. See if I can enlarge this. Just going to put this over here. Now, we're going to see what electron domains we have. So we have a tetrahedral structure here. So carbon is surrounded by 4 bonds. So each angle, that's going to be approximately 109 degrees. And this is also found on this carbon as well. This angle right here. This angle right here. This angle right here. Here, that's going to be these are going to be 109 as well. And this carbon is also tetrahedral, so these are also going to be 109. Now, for this carbon, it's surrounded by 1, 2, 3 electron domains. So you're actually going to have a trigonal planar structure. So they're each going to have a bond angle of 120 degrees. So these two are tetrahedral, so they'll both have a 109-degree bond angle, and this one is a trigonoplanar, so it will have a 120-degree bond angle. So those would be the bond angles for our specific carbons in our sample.